Hello, so today we'll be seeing a new topic which is called factors. Okay, so remember, while finding the LCM we used to find the multiples of a particular number. In case of factors, we have to understand what actually are the factors. Let's get back to the property of multiplication. Just during finding LCM, you used to find the multiples of a particular number. Here I have written certain multiples, like what are the multiples of 1? 1, 2, 3, 4, 5, 6. What are the multiples of 2? 2, 4, 6, 8, 10. Multiples of 3? 3, 6, 9, 12. Multiples of 4? 4, 8, 12. Multiples of 5? This much. Multiples of 6? This much. Multiples of 7? This much. So multiples of a particular number are those numbers which appear in the multiplication table of this number. So just as I can say that these numbers are the multiple of 2, conversely I can say that 2 is a factor of all these numbers. Similarly, I can say 3 is a factor of all these numbers. 4 is a factor of all these numbers. 5 is a factor of all these numbers. 6 is a factor of all these numbers. 7 is a factor of all these numbers. Okay, so let's analyze something. In the multiples of 1, we find a number 6. So we say that 1 is a factor of 6. Again we find here 6. 2 is a factor of 6. Again here 3 is a factor of 6. So we are observing that one number can have more than one factor. The same number 6 is having factor 1, same number 6 is having a factor 2, same number 6 is having a factor 3. So let's write down the factors of 6. We have written 1, we have written 2, we have written 3. Let's check the multiples of 4. We have 4, 8, 12. 6 doesn't appear, so 4 is not a factor of 6. In the multiples of 5, we don't see 6, so 5 is not a factor of 6. But in the multiplication table of 6, we find 6 is appearing, so here we will write 6 is a factor of 6. In the multiplication table of 7, it doesn't appear, so we will say that these 4 numbers are factors of 6. Now we will analyze something very important from this observation. We will try to understand the meaning of factor by these 4 statements. See, 6 appears in the table of 2, so 2 is a factor of 6. 6 appears in the multiplication table of 3, so 3 is a factor of 6. 6 appears in the multiplication table of 1, so 1 is a factor of 6. And 6 appears in the multiplication table of 6, so 6 is a factor of 6. What we conclude from these things is that 1 is the factor of every number, because every number appear in the multiplication table of 1. Next is every number is a factor of itself, because every number appears in the multiplication table of itself. 2 appears in the multiplication table of 2, 3 appears in the multiplication table of 3, and so on. So a number can have factors from 1 to itself. So if you have to find the factors of 6, you will first of all write that 1 is a factor, 6 is a factor, and then you will check all the numbers in between: 2, 3, 4, 5 and 6. For example, we are seeing here a number 10. So we will try to find out factors of 10. We know that the factors of 10 will lie between 1 and 10. In between we have 2. So we check that 2 5s are 10. 10 appears in the multiplication of table of 2, so 2 is a factor of 10. We check the multiplication table of 3, we find that 10 does not appear in the multiplication table of 3, so 3 is not a factor of 10. We similarly check for 4, doesn't appear. We check for 5, yes, it does appear, so 5 is a factor of 10. We check for 6, it doesn't appear. We check for 7, it doesn't appear. We check for 8, it doesn't appear. We check for 9, it doesn't appear, and the next number is 10. So we can say that these numbers are the factors of 10. Similarly, let's say factors of 12. We will start from 1. 1 is the factor of every number, and a number is the factor of itself. So we will have to check for all the numbers between 1 to 12. We check for 2, yes, 12 appears in the multiplication table of 2. It also appears in the multiplication table of 3. It also appears in the multiplication table of 4. It does not appear in 5. It appears in 6. Does not appear in 7, does not appear in 8, does not appear in 9, does not appear in 10, nor in 11, and the next number is 12. We have already 10. So these numbers are the factors of 12. Let's take a simple example this time. Factors of 8. So where we will go from 1 till 8. In between we find that 2 is a factor, 3 is not a factor, 4 is a factor, 5 is not a factor, 6 is not a factor, 7 is not a factor, and 8 is a factor. So these all are factors of 8. Okay, so if you know the concept of factors, then next session we will read about the highest common factor. In short, I can just say that just like we had lowest common multiple, a common multiple between two numbers which is the lowest, similarly for two numbers which we can say find out which is their highest common factor. For example, if it is asked what is the highest common factor of 12 and 8, so as the name suggests, the highest common factor, the common factor between these two which are highest, we find that 1 is a common factor for both, 2 is a common factor for both, and 4 is a common factor for both. So which factor is highest? Obviously 4 is the highest. So we can say that the HCF of 12 and 8 is 4. HCF of 12 and 8 is 4. So simply this is the concept of factors and the concept of highest common factor. The concept of highest common factor will be used in the method of reduction of fractional numbers. Okay, we will study that in detail. For now you can review it to get the concept of factors and highest common factor.